Thanks, David. So pleased to be here. Let me start with a story. If I was born 5 days earlier than my actual birth date, I don't know if I would be in front of you today. Because why I remember this is because oftentimes during high school, I had to fill in forms where they would explicitly ask, were you born before or after November 10, 1989, which is the day of the fall of the Berlin Wall. It did mark a day of transition for our country and a lot of Eastern Europe as well. I'm from Sofia, Bulgaria. How I remember this also is because of the times of corruption and kind of having that feeling of living through that every single day. And for example, the non-existence of freedom of speech, such as we have here. And it's crazy that this keeps going. And just last Friday, there was a big protest in Bulgaria about that. Actually, all this brings back culture, right? And anthropologist Nick Seaver urges us to think about algorithms as culture. Algorithms are not singular technical objects that we engage with as people, but instead they're culturally enacted through everything that we do to engage with them. So we really need to think about that because such as corruption, other huge problems like freedom of speech, right? They suddenly become part of culture, and that's the big challenge there. Like when we see them as normal and like the way we interact with them. Before we jump into the ethics and ethical implications of algorithmic systems, I want to take you to have an interdisciplinary approach, right? And this is why I think that it's very critical for us to be critical of the way we interact with algorithms, and especially to situate them into the socio-technical context which they're part of. And this is where having this interdisciplinary approach really helps. But before we jump into that, let's take a deep breath. 10 days ago, some time ago, I did a 10-day long meditation retreat. It was in the Tibetan Buddhist tradition called Vajrayana. And I spent some time learning about the feminine energy in the Tibetan tradition. It was held at a place called Tara Mandala, which brings up the Sanskrit word mandala, meaning a circle, a marker of supreme completion. How did the mandala come to the West? It was in part through the work of Carl Jung, who writes that the mandala serves a conservative purpose, namely to restore a previously existing order. What restores the new order simultaneously includes an element of new creation. In that new creation, that process is one of an ascending spiral going upwards, simultaneously returning again and again to the same point. The mandala principle in Tibetan Buddhism is something that really tells us a lot about the way we design algorithmic systems. To me, that relates to a key step in the design of pretty much any AI system today called principal component analysis. It's an algorithm through which an engineer finds a lower dimensional basis of high dimensional data. And this is how data sets with thousands of columns are transformed into virtueless linearly uncorrelated variables, which further makes the training, the algorithm much, much faster and computationally efficient. The mandala principle, though, in Tibetan Buddhism, and these are called principal components. The mandala principle, though, in Tibetan Buddhism helps us put dualities to work by realizing they don't contradict to each other, but instead reflect a single totality, so that nothing is left out. What happens when we fully apply this to designing AI systems? We start thinking about long-term frameworks and interdisciplinary approach, right? And there's a lot of translational challenges between different disciplines working around the AI ethics field. And this brings us to the work of Robert Sapolsky and human behavior biology, who really goes deep into the challenges of categorical thinking. Yet, classification is what AI systems are best at. One of the key learnings from human behavior biology is about that within category distinctions often get ignored, while between category distinctions get enlarged. For example, imagine that you're doing a test and the score to pass is 66. Suddenly, there's a world of difference between 66 and 67, right? Because they're close to the boundary. So we see that the pure nature of categorical thinking and classification is problematic only by itself without considering any other second-order effects. Much less attention has been put into designing algorithmic systems that think about finding the common ground between categories. This has been explored in the field of common sense reasoning, which includes intuitive physics, intuitive psychology, and building knowledge bases of common facts. In fact, and this is also very much informed by the field of developmental psychology, which studies how infants reason about the world. However, common sense is very intricate and very often uncommon. One of the founders of AI, Marvin Minsky, has a chapter in his fascinating book, The Society of Mind, called Uncommon Sense. In his work, he goes into the agents that are cooperating in the mind of a toddler where he or she is building a tower of blocks. In the real world, there's little in the behavior of a single block that tells us about the collapse of the whole tower. And this is what Buckminster Fuller calls synergy, behaviors of whole systems unpredicted by the behaviors of their parts. Synergy, Buckminster Fuller formed into a field called synergetics, and he really urged us to think about synergetics along with cybernetics. And that field was further developed by theoretical physicist Hermann Haken, who studied self-organization and emergence, self-organization of patterns and structures in systems, open systems, far from thermodynamics equilibrium. Naturally occurs in animal swarm formation, as well as biological and artificial neural networks, such as many of the algorithms we have today. Imagine what becomes possible when we employ the worldview of synergetics to think about the totality of perspectives and implications of algorithmic systems on the well-being of people, communities, entire populations, non-human species, and the planet. A totality in which contradictions coexist in each other and they do contradict with each other, but at the same time reflect that single totality. This is really what ties all my work together, and I'm really fascinated by those concepts and interdisciplinary worldviews. I'm really grateful to be part of the IEEE working group focused on implications of AI on the well-being of people, and really thinking about how do we incorporate indicator frameworks in thinking about AI well-being, and what would it mean for tech companies to have that approach and for AI policy to have that approach. I'd love to invite you in Paris, where the OECD is hosting a related meetings in a couple of weeks. And then we have one more day to submit to the International Journal of Community Wellbeing, where we have a lot of really great work from the academia in that field. I'm really glad to be collaborating with Dr. Urman Chowdhury at the responsible AI team at Accenture, where we focus more on research around the power balance between users interacting with their commander systems, and then also studying organizational structure and how it impacts fairness, accountability, and transparency efforts in industry. Thank you so much.